along with my friend Maulik Bhatt, welcomes you to the lecture series for building an autonomous line follower robot of Prevance 2K11. We have divided our lessons according to the parts of autonomous line follower robot. In this first lesson, we will be discussing about the concept of a line following robot and the parts of it. Starting with the introduction. A line follower robot is an autonomous robot that performs the function of following given path. This path can be of two colors spaced from each other considerably in wavelength spectra. The functioning of line follower robot quite resembles with us. We have got eyes to see, brain to process what we have seen, and arms and legs to act. In line follower robot, the sensors play part of eyes, controller plays part of brain, and motors play part of arms and legs. That means the line follower robot is divided into three steps: identifying, path using sensors, processing information, with correct logic, and in the end steer the robot along the path. Now, the line follower robot is divided mainly into 5 parts. First one is chassis or mechanical structure. Second one is motors and power supply. Third comes sensors. Fourth, microcontroller. And fifth, driver. Starting with our first part, chassis. What is chassis? It is basically the mechanical structure of our robot. It may be made up of either acrylic sheet or metal or any other material, but it should be as light as possible but yet robust. The robot side should be able to accommodate PCB, your sensors and battery. Motor should be in accordance with the size. Equal weight distribution and low center of gravity is must for stability of a robot. No wheeling please. Please do it with your own bike, not with the robot. That means to maintain stability, the robot should not lift when it starts from rest due to high torque. While your wheels, the diameter of your wheels should be appropriate, because the larger the diameter, the requirement of torque will be high. Starting with a second part, which includes motors and power supply. Let's first discuss about motors. In general, they include DC motors, stepper motors, and servo. DC used for high speed and low torque, stepper for high precision, and servo for industrial usage. We will be using DC geared motors as we need high speed and low torque to win the race. Well, it provides high RPM at cost of torque. The torque of DC motor is inversely proportional to its speed. That means higher the RPM of given DC geared motor, lower its torque would be. Since the armature resistance of DC geared motor is quite low when not energized, the two terminals of DC geared motor acts as internally short circuited. So if we put a multimeter on connectivity mode and check the connectivity of two terminals, it will show us short circuit. But when we give external voltage, under the influence of the torque, the DC geared motor will rotate into either clockwise direction or anti-clockwise. As for example, if I connect the red wire with the positive supply and black to the negative one, it rotates in the clockwise direction. And now if I reverse the supply, it takes the anti-clockwise rotation. So, in our robot, the two DC geared motors play part of two tires of our car connected to the motors, and the caster plays part of steering, as it can be steered into 360-degree span. Now let's talk about power supply. We use DC battery to provide power to our robot. Most widely used batteries are lithium ion and lead acid. Well, lithium ion batteries are light-weighted and small in size, whereas lead acid is heavy and bulky. But the main disadvantage of using lithium ion is its high cost, whereas lead acid batteries are quite cheap. But as weight is main concern in autonomous robot, the lithium ion batteries, as they are light-weighted and small in size, are currently in fashion. Now let's talk about the rating of batteries and its charging and discharging. Well, when fully charged, a battery will often be 15% above its rated voltage. When fully discharged, will be often 15% below its rated voltage. The DC batteries are rated in milliampere hour rating. Let's talk about the meaning of rated milliampere hour. Well, if a battery is rated as 1200 milliampere hour, it means that it can provide 1.2 ampere current for 1 hour. But as the load increases, this capacity of DC battery decreases. But mind well that the relationship between these two means increase in load and decrease in capacity are not linearly related. Well, you might be wondering that what is the difference between 1.2 ampere and 1.2 ampere hour. Well, 1.2 ampere hour means it has got capacity of providing 1.2 hour current for 1 hour, as I described above. Well, on the other hand, 1.2 ampere means it has got a capacity of providing 1.2 ampere hour continuously for quite long period of time, exclusive of the load connected. So that leads us to the end of our first lesson. Thank you.